it's all right like this.
Go ahead.
Thank you, miss.
Which board do you want?
As much as I can get.
Okay.
Because I like to move around.
All right.
I think it'll be good.
Hold on. No.
Here.
That's what this one. Yeah, right up where you at.
Okay. Move it just a little bit that way.
Okay.
All right. Thank you.
Well, you got the more of the ceiling.
Ceiling. All right.
Okay.
Thank you. Mm-hmm. All right, guys. So if there's no questions. Wow. I have such an wide array of colors to choose from today.
I have a question for you.
Yeah.
The homework. I was looking online. What website do you go? Not your website because I couldn't find it on your website. Is it on your website or on the My Math Lab?
What are you looking for?
The first three that you put on. You sent me an email saying that you had the first, I think.
Couple of homeworks. Yeah, it's a link on my website under the Math 160 section. It says Chapter 1 homework.
Okay.
Yeah.
I don't think I could find it. Okay.
Cool. Okay. All right. So, just to kind of remind you guys, last time we talked about the main thing about statistics really is that you have this huge, very often a very large population you want to say something about. And who remembers what's the word of that thing? The thing I want to be able to say about the population, like the percentage of everybody that smokes or whatever. Yeah, parameter. So we want to say something about the parameter of the population. But I don't have the time to talk to everybody in the population, either all 20,000 gross month students or all 310 million U.S. citizens, U.S. people living in the States. I don't have all that time in the world to say that. So I pick a small random sampling, trying to demonstrate random sampling. And I'll throw all this into my sample. And of course, from the sample, I can directly calculate a what? Statistic. I love it. And what we normally do is, and I kept referencing Chapter 7. Chapter 6 is actually the most important section. Chapter 7 is then the immediate applications of that important stuff. And that's why I keep referencing it. Because to cover our ass a little bit, and we're going to see the equations for this, if I get a statistic like 31% of gross months of my sample of gross month students like the parking here. All right. I don't know if it's really that high. So 31% of sample of gross month students. I want to be able to say something about the whole population. I can't just say 31% of all. That's a bit presumptuous of me. That's saying I got the best sample ever. That's screw. I'd want to say 31%, give or take some percentage, maybe 3 or 4%. So this piece is going to be something we study in Chapter 7, and it should make sense. The bigger that piece is, probably the smaller my sample was. That's why I have to cover my ass so much, give or take more to cover me for having such a small sample. If I take a larger sample, I'm more certain that piece will go down a bit. Right? Cool. And this is the kind of thing you always see. Thankfully, they at least show this when they tell you what percentage of people seem to want to vote for Obama versus some random GOP candidate. Somewhere they'll say plus or minus 3 or 4 percentage points, which is funny because if they say 42% want to vote for Obama and 44% want to vote for some GOP, and it's plus or minus 4%, are these guys necessarily ahead? Don't they kind of overlap then? Yeah. I don't know which one's ahead. So at this point, that's why I love the news. They just want to latch onto anything that people might watch them for. At this point, it doesn't mean crap, right? It could be some guy we don't even know about, suddenly come out of nowhere, riding some bus into town, and suddenly he's the front runner. It's like, who the hell is this guy? We didn't even know about. So just sit back and wait. So that's the main stuff from section 1-2. There's one little thing I wanted to talk about with section 1-2. And I totally forgot to bring my cards with me. Well, that's too bad for me. If I was to ask people to take cards from a deck of cards, and let's say you got the 7 of hearts, and you got the 2 of hearts, and you got the king of hearts, and you got the queen of hearts, and you got the 8 of hearts, are you guys at this point, if that happened, at some point you start thinking to yourself, what?
The deck is all hearts.
That the deck is all hearts. That I got several hearts from different decks and put together a deck of all hearts, right? Now, if you took 7 of hearts and you took a queen of hearts, at that point, is anybody suspicious? Hell no, that could happen. But at some point, it becomes statistically significant how unlikely that is. At this point, 2 hearts, all right, I'm fine with that, right? But if I have the first 5, 6, 7 people picking hearts, everybody's going to start going, he's got, that whole deck is hearts. Is it impossible that the first 7 people randomly pick it from a normal deck of cards? But what's more likely at that point? What's more likely is, hell yeah, I stacked the deck full of hearts, right? You guys kind of with me? Mm-hmm. So they do talk about something called statistical significance. And let me see if I can really make this make sense with an example of like a drug test. So, what do you normally do when you study a drug? What do you want to compare it against? Possibly another drug. A placebo, right? And what's a placebo?
Sugar pill.
Sugar pill. And that's just to check it against, if I only check the drug out and I say, wow, all these people got better, it might have just been the power of their own mind making them better. So if you give somebody a sugar pill and they get better, you're like, wow, you willed yourself to be better. You know, it's not the drug doing it. Might as well just take sugar and save some money, right? Don't pay $80 for a pill. So if what I'm looking for though is if I do a study and I find like 800 people, and on a sugar pill, on a placebo, 30 of them get better. But on my new drug, let's say 110 get better, right? Now the funny thing is, we can't officially say that that's evidence yet. But what do you think? What does your gut tell you? Is my drug effective, or more effective at least than a sugar pill? Yes. So that's statistically significant. Why exactly? Because it's so unlikely that this just happened to randomly be better than this. Like that 110 people on this just happened to randomly feel better than the 30 people on this. Right? So I could say maybe it's a 1 out of 1,000 chance that this group just happened to randomly have more people that got better than this group. You guys kind of with me? Cool. So you'll see questions like that. You'll see, if it turns out that there's only a 1 out of 1,000 chance this happened, is this statistically significant? Hell yes. Such a small chance that these guys would have done better just randomly. So it must have been the drug. Is it 100% sure that it was a drug? No, that's the thing that people hate about stats, because it's never 100%. But what I say to them is, stats is the branch of math that is more honest about real life. Is real life ever 100% certain? All right, so stats says, well, shit, man. We talk about real life. We're never 100% certain. We got to cover our ass sometimes with that uncertainty, and people just got to suck it up and say, well, that's really showing me real life. I don't know. You go into the surgery, there's a 90% chance you'll come out okay. That still means there's a chance you'll come out not good, right? I mean, that doesn't mean you're definitely going to come out good. Okay, how we doing? Okay, good. So that was like the last idea in that section 1-2 was statistical significance, right? Now, 1-3 is exciting. It's I think I warned you about this somewhere, but 1-3 is purely definitions of stuff. So bear with me, right? I'm going to try to make it interesting. We'll see if I succeed. So 1-3, it kind of goes in a decent order of I've already talked about a couple of these things. The very first few things it talks about is parameter and statistic. But what we want to do right now in section 1.3 is we want to get a little bit more into data. Types of data. If any of you guys heard the term quantitative easing, it's been in the news recently. You've heard it. If you listen to any news, you hear that. It's another way, it's like politically correct way of saying firing people, really. Quantitative easing is lowering the numbers that you have to deal with. So one type of data, there's like two main categories of data. One type is quantitative, and the other type is qualitative. Now, what seems to be the key word in quantitative? Quantity. So that one's the one that probably deals with numbers. Now, when you say numbers, you have to be careful. I always try to say this is like true numbers, like measurements and things like that. For example, if I have a football player and they have a number on their jersey, is that like a true number? No. Can you add that number to the person next to them and get something meaningful, right? If I'm number 27, am I better than number 30 or something because I'm closer to one? No, right? Just a different position, just a different person. It's my name on the field is another way to look at it. There goes number 27, right down the field. So that's going to be this qualitative, which is more, and actually this book has gone over to the other side. It calls it categorical, which is fine. And that name actually gives it right away. They're categories of things. They're descriptions of characteristics. They're like your name, names of things like that. So it could be names, categories. So it could be jersey number. It could be color of hair. It could be type of car. Those types of data points. And now you understand why do we as statisticians, why do we break it down? Which one of these can I do more with, analysis-wise? Obviously. Quantitative. Can I get an average hair color?
No.
Because what is brown plus blonde?
Nothing.
I don't know, bad hair day. I don't know what the hell that is, right? Oops, I need to get it retouched. I don't know what that is, right? It doesn't give me, I can't get it. In fact, a while back, and this is kind of evil, they took an average color of the universe. So you have all these different colors. Everybody realized that colors have certain frequencies of light, and that's why it's red when the sun's way down. That's why it's blue when the sun's way up, because the different frequencies act differently. So they took an average of all the frequencies, and they said the average color of the universe is beige. And it was like, well, that sucks. But did that mean anything? It didn't mean a damn thing, right? Doesn't mean anything. It just sounded terrible. Okay, so those two are pretty straightforward. You can't beat that. Which one would like social security number go in? Qualitative, because it's sort of like our name. It's like the warning of 1984 kind of stuff. We will be known as a number. Thankfully, it's not that bad yet. You guys still doing all right? Yeah? Okay, good. I'm going to skip a few things they do. I'm going to do it later, so we'll see. Right now, I want to break down these things further. Let me put it up here. Break down data types further. And you have these 4 levels of data. And this is starting on bottom of page 13. And actually 4 levels of measurement they call it, but you'll see why in a minute. I don't really call it measurement. Because the very first level of data is nominal level. And you'll see why in a minute. It's not exactly the same thing as one of the two over there that we've already talked about. But anybody ever heard the term plume de nom?
Plume the what?
Plume de nom. It's a pen name, right? Like Stephen King wrote several books under the name Richard Bachman, if you ever, and that was some good stuff. Well, anyway, so nominal, the key word there is name. So nominal data types are just names of things. So it's a lot like we were talking about over there. There are a few other things in qualitative that we'll get into in the second piece. This really is just names. So like Jeff, or like number 27 running down the field, or whatever, right? Number 27 jersey. So that's pretty easy, right? Nominal, just the name of something. As we go here, it's going to get a little more complicated to kind of tell which thing it falls into. It always falls, the data point always falls into the highest level. So for example, isn't 1984 the name of a year that happened, right? But it's higher up on the level of data because you can do more with it. So everything after this is going to be names also, but you can do more with it. For example, the second level is ordinal. So we have a guess as to what the root part of that would refer to. Organization or order, exactly. So these are things that fall into a natural order. Not that you put in order. If you alphabetize a list, it doesn't suddenly become ordinal data. You impose an order. This has to be order it wants to fall into, right? So it has an inherent order. So what the hell would that be? When you go to a restaurant, what do you sometimes see, a little like postcard looking thing sitting on the table? Okay, but what's sitting down there that you might need a pen to do something with? Yeah, a survey to see how they're doing, right? And very often those will have, if I had that, if I opened a restaurant and I said, rate my restaurant, is it good, poor, excellent, fair? Does something jump out at you about the way I've done that? What's wrong with the way I've done that? There you go. That's what I mean. These words, because of what they are measurements of my ability to run a restaurant or the food that my cooks cook, right? They should be in a certain order, and they're not. That's what I mean by inherent order. Now, if I start talking about cars, I see a BMW, I see a Ford, I see a Acura. They're not in order. Do they have to be in any order? No, they're just a bunch of cars I see. I can put them in alphabetical order, but they don't have to be. This doesn't make sense. I start filling this out. I'm like, screw you. You suck. You suck already. So of course, what order could it possibly be in? There's a couple maybe you can go.
Excellent.
Yeah, you can start excellent, good, fair, poor, right? And then you can draw your own circle and say, really feel bad right now. Got to go home. Your food really sucks, right? Okay, so that's ordinal. So there's still names. Excellent is the name you describe the food with, possibly, or experience, but it's more than just a name. It has an order to it. Third is interval. So normally, this isn't exactly true, but very often it's easy to think about these two as being the qualitative parts, and the next two as being the quantitative parts, because the next two are the things I can actually subtract and divide and do numerical stuff with, right? Here I can't divide Jeff by Sam. I don't know what the hell that would be. Interval, what the hell does interval mean? From mathematics, where did you hear the word interval?
Here, certain range.
A range, right? I have interval notation, remember that from algebra? Mm-hmm. From this to this. So what could you tell me about an interval? Like if I was on the interval from 1990 to 2000, I was in college or grad school. What could you tell me about that? I was in grad school for 10 years, right? Or college, or whatever. So that's almost true. Okay. The interval then, what can you do with it? What's the operation you could do? Subtraction. Data points can be subtracted. You can find the difference. So for another example, an easier little example, if I was born, I always like to ask you how old you think I am, and I'll just tell you. If I was born in 1972.
Same age.
All right, there you go. And when were you born?
86.
86. Right? That would mean, what can you tell me right there? I am
Older than him. You don't.
roughly 14 years older. We can get into the month and all that kind of crap, but still, the subtraction tells me I was born 14 years earlier than you were, right? So the subtraction makes sense. That makes sense. Notice it's not just that you can subtract them, right? Like, for example, you can subtract Social Security numbers, couldn't you? Or zip codes. Go to sleep now. Right, if you took zip codes and subtracted them, wouldn't you come up with a number?
Yeah.
Would that number mean anything? That's what I mean. So be careful. Not just that can you, but does it make sense? So there, that makes sense. Would dividing these 2 years tell you anything? So that's the next level, right? The next level are those things that division makes sense. And that's called ratio level. Because when you write like 8 divided by 4, 8 over 4, haven't you made a ratio? So it makes sense to call that the ratio level. What's up? Is it slide over?
Yeah, well, it's not on the other one.
I just need to hire a cameraman.
Go over there. Go over there.
It's good.
Yeah.
Good. So for example, if I didn't talk about years that we were born, but I talked about ages. Like if I'm 38 years old, and somebody else is 19 years old, 38 divided by 19 is 2. What's 2 mean?
That's good.
I'm twice as old as them. Oh, all right. Things happen. Cool? So there are a lot of numbers you can divide, but to be ratio level, the number you get has to mean something. And that one means I'm twice as old. Cool. So can somebody give me another example of a ratio type data? Age is ratio type data. Distance, I love it. If I live 20 miles away and somebody else lives 10 miles away, I'm twice as far away. What else? Cost, right? This costs $20 there, and this costs $5 there. It's 4 times as much over there. Screw that place. What else? Can somebody come up with a weight? Right? Can somebody come up? What's a general way of describing what works probably in ratio? Where's my? Oh.
Any measurements?
Yeah, when I measure stuff, right? Cool. So basically, almost any measurement is ratio. Now, real quick, just to go back to the earlier point, could you say, "Oh, that's that 38-year-old math teacher, that 38-year-old guy"? Isn't that like my name? That could be the way you reference me. My name is Jeff. That's one way to reference me. Another way to reference me is, "Hey, you in the freaky shirt," right? Little Mr. Mathlete over there, right? But another way to reference me is that 38-year-old dude over there. Hey, 38-year-old dude. Oh yeah, what's up? So it's nominal, isn't it? But the reason I call it ratio is because that's the highest level. You call it by what the highest level is. People always get confused. Well, it's both. Give me the highest one. Period. Right. If I come in second place in a race, that could be my name. Oh yeah, you're the guy who came in second place. You're the second place guy. That's you. Yeah, sure. Why not? I don't want you to know my name. Just call me that. But isn't that ordinal? First place, second place, third place, right? So I would say officially that data point, that data is ordinal data, because that's the highest level. I can't take second place minus third place officially unless you call it 1, 2, 3, and then maybe you can talk about differences. Okay, how are we doing? Those are confusing. I don't blame you. They do get a little confusing. Let me give you guys a couple to look at real quick. Page 17, if you have your book. If you don't have your book, it's still page 17. guys done this yet? Just sit and watch your teacher fiddle with the. Isn't it exciting?
Yeah.
Sorry. All right, nothing is working.
Is that pointed?
That's right. It's not on. It's my laser. All right, that's enough. All right, let me just read it to you then. That sucks a lot. No. All right. All right, that's nice. Okay. Well, the power button works. That's, or it did. All right, go on. Let me just read this to you then. If you don't have a book, just kind of listen close. So what level of data would this be? Types of movies: drama, comedy, documentary.
Nominal.
Nominal. They don't have an order. I know that you might have your favorite and your least favorite, but they themselves don't have to be in an order. What about, oh, here's a good one. This is the one I want to talk about. Temperatures in Fahrenheit.
Is ratio.
Ratio.
Not ratio. Yeah, interval. Here's the reason. Another thing that ratio has to have is it has to have what's called an inherent zero. And the reason for that is, does 0 degrees Fahrenheit mean there's no heat? Because you can get colder, right? I know we live in San Diego, but I've heard other places it can get cold.
Yeah.
So there must be something that is twice as hot as a 0 degree day. Do you agree?
Yeah.
What's twice 0?
0.
So it couldn't possibly be ratio. And twice as hot as 60 degrees is not 120 degrees, right? If it's 60 one day and then it's like maybe 78, 80 something, I'd say it's twice as hot today as it was. I mean, do you see what I'm saying? It's because of the fact that 0 is not in the right place. Anybody know either a third temperature? I know we got Fahrenheit and Celsius.
Kelvin.
Kelvin. Kelvin is the one you hear a lot in chemistry and such because Kelvin is the true heat scale. It actually measures what's known as kinetic energy, how much the atoms are moving around. When the atoms stop moving, that's what's called absolute zero, right? And that has a true 0 then. 0 means what it's supposed to mean. What is 0 supposed to mean?
Nothing.
The absence of what I'm measuring, right? So length is ratio, because if I said I caught a fish that was 0 inches long, that's another way of saying I caught no fish, right? My fish had no length. It didn't exist, right? Profit even. If I said I made $0 profit, that's an absence of profit, absence of what I'm measuring. 0 degrees Fahrenheit is not 0. It doesn't mean the absence of heat. Do you guys get the idea?
Yes.
Cool. So temperature's a little freaky. You can say it's twice as hot, but it doesn't have to actually be 2 times the number. The math doesn't jive with how I feel, right? Don't have to wait for 120 to be twice as hot. It ain't twice as hot. It's not 120 yet. No, it's twice as hot. Leave me alone. There. What about, here we go. Years in which movies were released.
Interval.
Interval, yeah. So definitely years in which things happened will definitely be interval, because you can always subtract. You can say this movie came out 11 years later, because the one came out in 1989, the other one came out in 2000. It's 11 years later. The difference makes sense. What about critics' ratings of movies on a scale from 0 stars to 4 stars?
Ordinal.
So I could see ordinal. That's the first thing I would look for. The funky thing about some of these is I'll accept more than one answer sometimes. So like on a quiz or a test, I say explain your answer. So who had a different answer for that besides ordinal?
Ratio.
Why do you think it might be ratio? It could be more popular, but what's ratio have to, what do you have to be able to do and have it make sense?
Divide.
Yeah, divide, right? So I could almost see that, because you can say if it got 4 stars and another movie got 2 stars, then the first movie got twice as many stars. 0 means you got no stars. So see, it kind of depends on the way that you're looking at it, right? Somebody else could say, well, you can't divide stars. And somebody else says, no, I'm talking about how many stars. So both ways actually are good. So if you're looking at it one way, you can't do certain data analysis on it. So that's why I ask you to explain yourself. I would even take interval possibly. You could say that got 2 more stars than the other one did. 3 minus 1 is 2 more, right? Voltage measurements from somebody's house. If you measure the voltage. Yeah, it's going to be ratio. If it says measurement, that's a really good key word, except for temperature. That's why I said almost any measurement. See, I know how to cover my ass too, so temperature doesn't follow that. Okay. Cool. So that does take some practice to get used to that. The way I do it is I pretty much know if it's going to be either nominal ordinal or interval ratio, right? I can tell is it a real number or not a real number. It's just a name of some kind. And then I can figure it out between those two. If it's a real number, does division work? Make sense? No? Interval, yes? Ratio. For nominal ordinal, that's pretty easy. Does it have an order it has to be in or no? Right? Cool. So the last little thing from this section, and I think they actually do this a little too early, but it's all right. Discrete versus continuous. That word continuous, you might have heard it before possibly. What do you think that word means? If you think about measurements or counting things or something, what would continuous mean?
Forever.
Keeps going.
Infinity.
Doesn't necessarily mean
It
infinity.
means 1, 2, 3, 4, 5, 6, 7, 8.
And that's not, now be careful now. See, now are you being continuous? Now look, watch. If I draw a number line, here's 1, 2, 3. So if I say, okay, it could be 1, 2, 3, am I continuously moving?
Well, it will be 1, 2.
Am I not skipping a bunch of stuff in the middle?
Yes.
Continuous would be,
Everything in it.
I can hit everything, right?
Right.
So measurements are continuous because how far away am I right now from my house? It's not exactly 20 miles, right? If somebody asked me, how far away do you live? I'd say 20 miles. I wouldn't be a complete dork and say I live 19.8543 miles away. Could I? Could I?
Yes.
So couldn't that data point, couldn't the distance take on any value between 0 and something? Any value. It won't skip anybody, will it? That's continuous. Discrete skips. So the number of doors on your car, could it be 1.8?
No.
I don't care how bad a door works. It either is or ain't a door, right? Do you guys get the idea? So discrete, 1, 2, 3. It can only, or it could be 1, 1.5, 2, 2.5, but somehow it can only be certain values. Cool? So this could only be certain values. We normally call it countable values. Continuous is not countable. You can't count all the possible weights of a book, because a book could weigh 8.93 pounds. It could weigh 8.931 pounds. It could weigh 8.9314 pounds. Holy shit, I can go forever, right? And I haven't even gotten away from 8.9 something pounds. So it would go forever. I can't count that. Not countable. And it can take on any value in a continuum. Continuum is a cool word, right? Because it's got 2 U's in a row. I love that.
So would you consider pi a continuous number?
Oh, I see. Now be careful. I want to really make this clear. If I said my backpack weighs 8 pounds, is that representative of continuous or discrete data? Wrong. Now here's what I want you to realize. The number is not the data, right? The number is just an example of a data point. Am I even being exact with that number? What did I probably do? I probably rounded the damn number. So when you look at is it continuous or discrete, you think, what could it be? Could the weight be 7.98, and would that make sense? So that's continuous, right? So be careful. Just because I give you a whole number doesn't mean that's discrete. These are not based on what the number I give you. These are based on what the data values could be. They describe the data point itself.
Is there any other way to have a continuous data as like instead of measurements? Like, because you've talked about measurements such as weight, distance, height, and things like
Those
that.
are the easy ones. I mean, off the top of my head, I probably can't come up with one, but it's still a measurement. It's a measurement of how long you've been on this earth, right? So it's hard to come up with one that's not a measurement. It's been a while since I even tried to think of one. People always try to say that there's you could do it with colors, but there's no way. If you're trying to assign words to all the different colors, you can't assign all the words and have it be really continuous, right? You can get the 128 pack of Crayola crayons. That's still not continuous, right? There's discrete crayons. I think you're with me there. So it's basically measurements. I'd have to really think hard to come up with something else. Yeah. And that's why it's continuous, because measurements, I could be more and more and more precise. But be careful about that too. When I say measurements, I think we all think about the same thing, but counting the number of doors on your car is also measuring. True? Not like what we think of when I say measure, though. You're still measuring something. Number of pages I can type per minute. That's what? Discrete or continuous? The number of pages I can type. Or number of words, I should say. Yeah, that's discrete. Cool? Because I can't. You're not going to say I can type 80.14932 words. What? No.
If
Do we have a? Oh.
If the example like a 45 words per minute is what they call, it's going to be complete or not. If we typing about 45 words per minute.
45 words a minute.
Yeah.
So that's, and it doesn't depend on the 45. It depends on what could it be. It could be 45, 46, 47. That's discrete, right? Nobody's going to say you type 45.1111 words. What's that mean, right? So that would be discrete data. Okay. Yeah. Yeah. If anything, if you can say the number of blank, that's more than likely discrete. The number of words I could type in a minute, the number of people in a room, because that's a good one. I like that one. There can't be 3.9 people in a room. That 0.9 person freaks me out. Right? I don't care what's happened to them, what's going on. They are a person or they are not. All right? So that's definitely discrete. Yeah, cool. Okay. Maybe. All right. So is the volume of cola in a can of regular Coke is 12.3 ounces. Is that discrete or continuous?
Continuous.
Yeah, because it could take on any value. So how about if I said the amount of nicotine in a Marlboro cigarette is 1 milligram? Don't let the 1 throw you off. It's a whole 1, but I don't care. It could be 1.0039. It is rounded, right? A car is randomly selected at a traffic safety checkpoint, and the car has 6 cylinders. Now, I've had some bad cars, but they still had either 4 cylinders. They didn't have 3.289 cylinders, right? Now, what other types? How many cylinders could you have in a car?
12, 16.
Yeah, exactly. You can't have 4. I don't know what that would even mean. We didn't finish building this one, but we'll stick it in there. 0.2 of a cylinder. Yeah, thanks. It's just gonna sit there. Yay. Okay. So that section, I think what gets people down about this section normally is the nominal ordinal interval ratio. That gets a little bit confusing, and I understand that. That's why I want you to explain your answer so I can at least see, do you understand the word, what the word means, and are you just kind of misinterpreting the situation? Or there are situations that can be seen several different ways. So that's why I want to let you give you a chance to explain your answer. Okay. Oh, cool. I kind of warned you about this, right? You guys doing all right? This first chapter is difficult as a student because it's just definitions. And trust me, it's not easy as a teacher either to get through this. But we all have to talk the same language in here. So I want you to know what I mean if I say these things. Oh, yeah.
You said like nicotine in the cigarette is continuous, discrete, because of
Careful now. The nicotine in a cigarette is 1 milligram. The nicotine in a certain cigarette is 1 milligram.
So it could be like a shape of something would be continuous. Like the Coke inside the
The way you think about it is, don't look at the number they give you. Think about what could it be. If I measured a different cigarette, how much nicotine might it contain? Could it contain 1.03946 milligrams? Do you see what I'm saying? Could it only contain 1 or 2 or 3 milligrams? That would be discrete. But it's definitely continuous because they can add just a little more beep, and then it's 1.01, right? So I can make it whatever I want to in a continuum of values. Do you get that? Don't look at the number they give you. And I will do this to you also. Don't say, oh, it's a whole number. It's discrete. That's not the idea, right? In fact, forget about the number. Think about what could the data value be. If it's the weight of a backpack and they say it's 8 pounds, cover the 8 pounds. Say weight of a backpack could be 7.921. And they round it. So that's continuous. It could be that. But you can't have 1.7 cats, right? It's still a cat. I don't care what you did to the poor little thing. It's still a cat. That's terrible. What an image. It's still a cat.
Well, one of the cats is pregnant, so
Well, either you count them or you don't. They're cats or they're not. They're not like, oh, it's half a cat right now. I like that. All right. So last little thing here. I'm not going to do too much more because this is kind of hard to sit through. I understand. Section 1.4 is really a funny section to me. And I think I might have said a little bit about this before. One thing that people don't realize, there were some elections in the past. I don't know if you've heard in that the past decade that we just came out of. They were a little contentious, right? In fact, one of them they couldn't line up the right circle with the right name and all this kind of stuff. Did you guys hear about that in your history classes? All right. There's a lot of wrangling about which candidate gets listed first on a ballot. And you might not hear about all this, but there's a lot of different rules based on where you are. Maybe it's the party that's in power. Their guy gets listed first. Or in some other state, it might be the number of people registered for that party. That person's name will get first. Why would people care?
It's easier to find.
Easier to find. So if somebody walks in and has no idea, they don't watch any news, they just wander around and say, hey, you going to vote today? What? Sure. All right. They walk in. What's most likely going to happen, they've actually proven this in studies, is that the person who gets listed first gets an automatic bump just because they're listed first. So hell yes, people are going to be wrangling, because what's happening here recently is we get so close, they do a recount and all this stuff. Well, if you're listed first, you got a little bump. So you're like, okay, good, maybe that's enough to take me, above the other person. Do you see what I'm saying? So the ordering of things to choose, the ordering of questions that people ask, right? If you ask a bunch of questions, you get somebody upset about the environment, and then you say, would you want the president to have the authority to pass environmental? You might be more, yeah, I do. But if you ask that question first, you might, I don't want the president to have that much power. Do you see what I'm saying? So a lot of times surveys are designed so they ask you questions leading you up to the one question they want to put on the news that night. Oh, 78% of the people that responded said this. Holy crap. Well, yeah, you led them that way. Do you see what I'm saying? So that you always have to be able to put your survey out for other people. And they say, your survey's crap, your data's crap, we're not putting that on, right? Do you guys see that? So part of this is about that. The other part of this is about something I find really, really funny. And I don't know if, I don't think they have this one in here. They used to have an example like this. Can you tell me what's wrong with my conclusion to this? I go out and watch a bunch of people playing basketball over the course of a week, right? Nice random sample. And I conclude that playing basketball makes you taller.
No.
Can you understand why somebody, now that's a really extreme example. What mistake did I make?
Did you measure?
Sure, of course I did. I measured them, right? Somehow I said, hey, can I measure you?
Taller for other reasons.
So say again?
So you assume they were short before playing basketball?
So one thing is I do make that assumption that they were short before they started, but that actually leads right to what the real heart of it is. There definitely is a correlation between how tall you are and the likelihood that you will play basketball. I'm not saying that no short people play basketball, because I definitely played basketball a lot, and then I got to a point where I wasn't going to grow anymore. Like, well, there goes my basketball career, right? Thanks, Dad. He was an inch shorter than me. Thanks for the genes. But what is the real answer here? What really did the researcher do? I've got height and I've got playing basketball. And he decided this affected this.
You're assuming
You assume
causality.
that basketball.
I like it. That's a beautiful word. Causality. If I see a correlation, I can't say that one causes the other. We do that all the time. I don't know if I want to give you this example, really. No, I don't. But a lot of times we'll say, these students took this course, and then they did better on this test. This course makes them better. But they had to sign up for the course. They were more motivated already. Do you see? So it's sort of like I can't use that data to prove anything because they're self-selected. They were more motivated. Maybe they would have done better already. And we get that all the time. And like when I headed up the tutoring center, I had to be real careful when I did data analysis because the students who come in very often for tutoring are the students who are really good already because they know what they have to do, right? I'm not saying that everybody that comes in there already knows it, but overall, a lot of them already come in, they're good students, and that's what good students do. So I can't say, oh look, the Math Study Center caused these students to do better, but we do report those numbers, but I don't say, oh look what we're doing, because I can't. Right?
And I disagree with you. Granted, a lot of students that do go to the Math Center are good. Some are horrible, like me for example, but yet I'm at the Math Center
True.
every day.
So I want to be real careful. When I say something like that, I am never going to say it's true 100% of the time. Remember, I'm a statistics teacher. We're never 100% sure, right, about anything. So I'm not saying there are counterexamples. For example, studying more, shouldn't that make you do better on a test? But aren't there people that have no idea how to study? And they always come to me and say, I looked at this problem for 4 hours, Mr. Wall. I didn't know. What good is that? 4 hours wasted. Pass the damn problem. Write me an email, something. Say, how do you do this problem? I'm going to keep going. Thank God. That's the right way to do it, right? You don't know how to study. So you put in there, I studied for 8 hours and I got a D- in your test. That's going to throw my data off because you studied wrong. You see? So I can't talk about outliers. There's always exceptions to a rule. I love the example about the number of beers you drink, like late night, and then the grade you make on the 7 a.m. test you have the next day. Don't you think there would be some kind of a correlation there? Don't you think some kind of maybe rough correlation? Would you have done better if you hadn't drunk that much the night before? Probably, right? Aren't there going to be exceptions to it, though? Aren't there going to be the people, no matter how sober they are, they don't know what the hell they're doing? Or people that don't have hangovers and can hold a lot of alcohol and wake up the next morning and I'm ready. No problem, right? Do you guys kind of see what I'm saying?
Yes.
Okay. So the way you said it, I love it. Correlation, oh, this sounds like a note because you're slowing down. Correlation, a few people got my point there. Correlation does not imply causation. You can't say just because two things seem to happen all the time together, that doesn't mean one causes the other one to happen.
Doesn't always imply causation.
Exactly, doesn't always imply, right? In fact, I'd have to do further studies to really see which way it goes. Is this causing this or is this causing this? The old chicken and the egg thing, right? Which came first?
Correlation doesn't cause what?
Correlation does not imply causation. So what that really means in English is if I see a relationship between two things, it doesn't mean for sure that one caused the other one to happen. Like I saw a relationship between how tall people were and they're playing basketball. So I said, oh, so basketball makes you tall. I'm going to start playing. Oh, I feel that already. No, ain't going to happen, right? Okay. Oh, let's see. One last thing here. Let me ask you this question. Here's a good example of this. Which one do I want to do? Yeah, not that one. Based on a study showing that college graduates tend to live longer than those who don't graduate from college, a researcher concludes that studying causes people to live longer. So on this homework, what you need to do is don't just say, that's crap, and move on. You need to give me a better explanation. That explanation sucks. That reasoning sucks. What's a better possible explanation for what's going on there? Why would people who graduate college tend to live longer?
They're more educated, so they know maybe like how to take care of themselves or certain things to avoid.
So a lot of schools have nutrition requirements for graduation, so you have to take some kind of a class that includes in it how to live correctly and what to eat. So that's a definite possibility.
Better income.
Better income, which means
Better
better job, which means
Less
better
stress.
standard of living, which implies that you have insurance for one thing, right? You get a good job, they have good benefits, you get good insurance, you're probably going to live longer than you would have, right? Now, aren't there going to be exceptions to the rule? Of course there will be. When people read this, they think, even that's not really perfect, though. They think, if I go to college, I'll live longer than I would have. That's not what it means. You can't say that for sure, right? There seems to be some relationship there, though. Okay. All right, cool. I think that's plenty. So, what I really want to do is, I know I might lose a few of you guys. You might wander away and head to your car already or whatever. But I really want you to stay with me. Go on this quick little tour. We're going to go out by my office and go see a couple of key places in the tech mall.